Welcome to the MS SQL Tips webcast, SQL Server HA and DR strategies and cut your costs, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast host. Joining me today is Joey D'Antoni, who will discuss how to implement high availability and disaster recovery strategies for SQL Server without having to spend a fortune. Before we get started, if you have questions, you can submit them at any time during the webcast by entering your questions in the question area in your presentation controls. We will try to answer as many of the questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, you can also use the question area to let us know. If you're not already a member of the mssqltips.com community, we invite you to join. You can go to mssqltips.com and sign up for our newsletter, read tips, download white papers, watch videos, and post your SQL Server questions to be answered by our community members. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with the links. So at this time, I'm going to turn things over to Joey, and he can begin the presentation.
Thanks a lot, Greg. I'm Joey D'Antoni, and today we're going to talk about SQL Server high availability in DR and how you can save a tremendous amount of money in implementing in your organization. A little bit about myself before we get started. I've been working with data platforms for over 15 years in very large companies as well as much smaller organizations. Currently, I'm a solutions architect for Anexinet, which is a small consulting firm outside of Philadelphia. I frequently talk on database administration, big data, and career management. And HA and DR has really been a specialty of mine. I grew up in a hurricane zone, and I've worked in a couple hurricane zones, so I'm always kind of thinking about high availability and disaster recovery. I'm the co-president of the Philadelphia SQL Server Users Group. If you're in the area, we're having a SQL Saturday on June 7th, and we'd love for you to attend. And I want to make sure you can restore your data because that's the most important part of your job as a database administrator. I blog about a lot of these topics at jdantoni.wordpress.com, and you can find my information there. I'm at jdanton on Twitter, and I'm also on LinkedIn and Facebook. So hit me up, and we can connect. So today's agenda, we're going to give a high-level overview of the requirements for SQL Server high availability and disaster recovery. Traditionally, these have frequently involved things like shared storage. Almost always we needed a SAN to have a cluster, and that was always a big challenge for many small organizations. Additionally, a lot of the DR options in SQL Server, such as always-on availability groups and database mirroring, in some scenarios required enterprise edition of SQL Server, which can get really expensive. So we'll highlight a three-step strategy for saving cost in SQL Server high availability and disaster recovery. We're going to start off with licensing. SQL Server used to be very affordable in terms of databases. I've worked a lot with Oracle and SQL Server, and generally speaking, SQL was always cheaper, and it still is to an extent. But starting with SQL Server 2012, Microsoft introduced core-based licensing for Enterprise Edition. Standard Edition licensing didn't change particularly much. However, Enterprise Edition generally got a lot more expensive for most customers. So we'll talk about some strategies to mitigate those licensing costs. Then we'll talk about SAN hardware costs. SANs are one of the more expensive focuses of any IT infrastructure. There's a Gartner study from about a year or two ago that said SAN storage costs on average $3,300 a terabyte. Next time a manager asks, but storage is cheap, I can get a 3 terabyte drive at Best Buy for $100. Yes, you can, but it's not exactly enterprise storage. So we'll talk about how you can save hardware costs using this solution. And then lastly, we'll kind of cover the cost savings and summarize where the gains are. There's a whole lot of gains that can be made here, especially if it fits your needs and model. So at a minimum, to protect SQL Server, you always need three things. You need software features such as that are within SQL Server and within Windows, such as always-on availability groups or always-on failover clusters. Both of these solutions protect against different things. What a failover cluster is typically going to protect you against is a server hardware outage or a problem with the operating system. So if either of those two events happen, your server will be able to fail over to another node in the cluster and come back up with a minimum of downtime. You need some sort of replication for DR. And this is where always-on availability groups come in. The challenge there is an Enterprise Edition only feature, as is database mirroring, asynchronous or high-performance mode. which is fairly limiting because the high safety mode, which waits for a transaction to be completed on a secondary. So when you're doing that, you can't have your secondary be too far away, or it will impact your performance on the primary server. And then clusters for high availability protection. One of the problems with a traditional cluster is the SAN is a single point of failure. One of my favorite stories about the SAN being a single point of failure. I was a DBA for a long time before I started consulting. One Sunday morning, fortunately it was about 9 a.m. and not 2 a.m., I got paged for a database being down. I logged into the server and I was expecting to see, it was a Unix server, not a Windows server, but I was expecting to see a command prompt, and a customized command prompt, and I logged in and I didn't see anything. I tried to do a listing on the file system. I still saw nothing. The server was in a clustered environment, so it should have been available. I couldn't get in through either node. Well, I called my boss and said, I don't think I'm going to be able to bring this database online. And she said, oh, I forgot to tell you. Our major storage vendor came in to decommission a SAN, and they took the wrong one. So even though we had a cluster and we had a brilliant high availability solution, we still had a single point of failure in that SAN. And that took a whole lot of databases down. So just because you have a cluster doesn't mean you're completely protected. Let's talk next about how we can simply cut cost. So if we can provide high availability in DR within SQL Server Standard Edition across a pretty big, reasonably sized server like we typically buy, we can save around $74,000. It's a pretty huge number in just SQL Server licensing. Second, we can reduce the cost of software assurance. We'll talk a little bit more about software assurance in a few slides. One of the things you kind of need to know is that software assurance used to be somewhat optional in the SQL Server space. In Oracle, you've always had to buy support just in order to get patches. Traditionally, software assurance with SQL Server was something where if you wanted upgrade rights to the next version, you would buy software assurance, and it's typically about 25% of your total licensing cost. Well, really since the 2012 licensing changes, Microsoft has really changed the purpose of software assurance, and it encompasses much more than upgrade rights. It's more like a maintenance program. So it's basically a requirement for HA and DR environments, and we'll talk a little bit more about why that's a requirement later. And then the biggest chunk of this number, which we'll cover in more detail, in full detail later, is traditionally our clusters have required on shared storage. This number is a total cost of ownership for 5 years of $735,000, really $736 when we factor in the rounding. SAN total cost of ownership is very expensive. The storage is expensive. You have to buy support from the vendor. And you may even need to have full-time employees dedicated to managing the SAN, or at least consultants. So shared storage can be really expensive, and it doesn't always give you the kind of performance you'd expect. So here we're going to have a quick poll question about software assurance. And I'm going to launch this poll. Please answer yes or no. We'll give it about 10 more seconds. Okay, and our number on that was 59% of you said yes, you purchase software assurance, and 41% of you said no, you do not. One thing we'll talk about later is why, if you're probably watching this webcast, you're probably going to have to start buying software assurance. So it's definitely going to be a consideration going forward. So let's talk about implementing the SANLess cluster. SANLess cluster is probably the easiest and most cost-effective strategy for high availability and disaster recovery within SQL Server. It comes very close to replicating a lot of the features that are in always-on availability groups with way less administration hassle, and using standard edition. So what SIOS Datakeeper Cluster Edition provides to a SQL Server failover cluster is it adds a host-based block-level replication to synchronize storage, local storage, in primary and standby servers. We can enable high availability and disaster recovery in SQL Server Standard Edition. So without the expensive cost of SAN replication, and we manage replication and recovery at the host operating system level. So we manage everything through SQL Server Windows Cluster Failover Manager, just like we would for a standard SQL Server. And we can deliver geo-cluster functionality like array-based storage with significantly more configuration options. So we have the ability to replicate locally, remotely, into the cloud, or between SAN and SANLess clusters. So we get a great deal of flexibility, and it's very easy to configure. I have VMs running on my laptop that are using this technology, and it feels almost exactly the same as a traditional SAN-based cluster. However, there's one huge benefit. In a traditional SAN-based, well, there's multiple huge benefits. Your cost savings are great, but from an HA perspective, in DR, in a traditional SAN-based cluster, there's only one copy of your data. So when we go back to that scenario where the vendor came in and decommissioned the wrong SAN, I was in trouble. I pretty much had to recover everything from backup tape. Had I been using a SANLess cluster, my second server would have had an additional copy of my data. So instead of just shifting the service between the nodes and shifting those SAN disks, I'd have a true second copy. So when I failed over, my data would still be there. So it gives both HA and DR protection, so there's no single point of failure. And additionally, we enable other architectures. So we could, one of the limitations of SQL Server Standard Edition is we can only have 2 nodes in a cluster. However, we could have a third node where we were shipping data that wasn't necessarily part of our cluster, but just a DR option. So we do get a great deal of flexibility with that. So when we implement a SANLess cluster, we're providing HA and DR with SQL Server Standard Edition. This is a pretty big deal because DR is a challenge in outside of Standard Edition. Database mirroring has been marked for deprecation in SQL 2012, which means typically within 2 to 3 major releases of SQL Server will be gone. That used to be less of an issue because Microsoft released every 3 to 5 years. Now they're releasing every 2 years, so it may be gone sooner than later. I ran into a feature, and I'm forgetting what it was. It may have related to in-memory LTP that was not supported for database mirroring just in 2014. We reduced the cost of software assurance. This is a little bit of common sense, but just to understand, software assurance is based on your total licensing cost. So if we're implementing our disaster recovery without using something like always-on availability groups where we're having to buy enterprise edition licensing, and we're using standard edition because we're using a SANLess cluster, that's going to greatly reduce our total license cost. Therefore, we're not going to need an enterprise edition license. Therefore, our software assurance number is going to be a lot lower. SAN storage. We'll talk a little bit more about the SAN, but I rarely hear any DBAs having good stories about SANs. So that's definitely an option. It adds configuration flexibility. Like I said, we can replicate to the cloud, we can replicate locally, we can replicate to a second site. And it's all done using block level replication, so it's really, really fast, really efficient, and very easy to configure. There's definitely a low administration cost here. Lastly, it enables the use of high-performance SSD, and I know you can buy SSD in enterprise storage arrays. I've done it before. It's really expensive. I have a couple of SSDs running in my laptop. I can get a terabyte. We can get a terabyte drive for around $500. You can't do that in enterprise storage. You're looking at $8,000 to $10,000 for that same terabyte of storage. So it's very expensive. However, if you're using direct attached local storage in a server, you can get that quite affordable, either via Fusion IO or just buying 2.5-inch SSD drives that are server grade. Oh, I apologize for TweetDeck, sorry. I have a couple of questions that I'll answer real quick. Can it replicate across domains? Yes, it can, but not within the same failover cluster. That's a limitation of Windows Server failover cluster, not a limitation of the software. And then the other question I have is, with SQL Server 2008 or 2012, can we have geo-clustering with SANLess clustering? And the answer to that is yes. In both versions, you can. The difference being that in SQL Server 2012, you can spread that cluster across multiple subnets, whereas with SQL Server 2008, you have to have a stretch VLAN, so both nodes have to be in the same subnet in order to do that. So let's talk about HA and DR with SQL Server Standard Edition licensing. And before we get on to the next slides, I'm going to release a poll. Have you recently moved from SQL Server Standard Edition to Enterprise to do HA and DR options? Give this a few more seconds. And we have about 25% of our respondents who have moved to Enterprise Edition, and I'm guessing that's to implement always-on availability groups, which tends to be pretty pricey. So let's get talking a little more about SQL Server licensing. Why not just use Standard Edition in a standard environment? SQL Server Standard, because it's a lot cheaper, right? We can see $8.99 per server plus $209 per cow, and high availability is included. Well, traditionally, and out of the box, SQL Server Standard Edition has some drawbacks that make Enterprise Edition necessary in standard clustering environments. High availability protection in SQL Server is typically provided by SQL Server failover cluster instances, a feature that's integrated in Microsoft Windows Server failover clustering. It is finally available in all editions of Windows Server. In the past, before Server 2012, you had to provide Windows Enterprise to use that, and now it's all in Windows Standard. The high availability feature in SQL Standard that leans a lot of companies towards using Enterprise Edition leans more to the DR side. Database mirroring, and this started in 2005 SP1 when they introduced it, or excuse me, 2008 was when asynchronous was introduced. Database mirroring has two modes. There's one mode called high safety. This is synchronous replication. What happens when you're using high safety mode is if a transaction takes place on your primary server, that transaction is not committed on the primary until it reaches the transaction log on the secondary server, which is fine if your servers are pretty close to each other and not on the same data center, or in the same data center. But when you start talking about replicating between, say, Philadelphia and Chicago, and there's definitely a latency involved there, you can definitely feel some impact on the primary server. That's just one consideration. So in order to not have that, you need high performance mode of database mirroring, and that's only available in Enterprise Edition. And what that does is allows it to go to the secondary asynchronously, so the transaction doesn't need to reach the log. One of the other challenges about using that methodology for DR is you also have the labor cost of maintaining SQL Server agent jobs and SQL Server logins across all involved nodes. Unlike a cluster where all that stuff just moves with the instance, you need to manually move it in a mirroring scenario. Traditionally, Windows Server failover clustering and SQL Server clustering couldn't really be used for DR because of its dependence on shared storage, which couldn't span multiple sites without a really expensive configuration involving array-based replication. It can be used for multi-site protection, but it requires a SAN at both your primary and secondary sites. So you have two SANs, which are pretty expensive, and you're locked into a single vendor for both arrays. It generally requires the purchase of additional software from your storage vendor, and more importantly, it's just harder to do a restore. I've been involved in some SAN-based replication scenarios, and while the technology is fairly solid, you're just greatly increasing the number of people that need to be involved in your restore, whereas typically you might have a DBA. You might have a DBA just doing a restore and maybe a sysadmin. For the geo cluster, you frequently have the SAN team, and the SAN team as well as the network team in some cases. So it's just a lot more complicated. And then lastly, the other enterprise edition option would be always on availability groups, but that's going to greatly impact our total cost of ownership. So here we're gonna look at what SQL Enterprise Edition costs. Starting in Server 2012, Microsoft introduced core-based licensing for Enterprise Edition. Before, we could license either by sockets or by cores. By sockets or by CAL and server licenses. So that was something we did at one of the larger companies I worked with. We bought a CAL for every user in the company. So every server we implemented was only $10,000 of incremental cost. So we knew we had a fixed cost of our user CALs, and in that company it worked out to be pretty cost effective. Unfortunately now we only have the option of using a core-based licensing for Enterprise Edition, so that's a real challenge. So if we're looking at a 1-2 socket, 6-core server, a CAL is a client access license. So basically you buy one CAL per user of your database. In that case, we bought one CAL for every user in the company. But now you can only license by cores. So in this case, we're talking about a 12-core server and $83,000 roughly of licensing cost. And this isn't even something like a data warehouse server where you might have 4 sockets and a much higher number of cores. So this is a real challenge. So reducing the cost of software assurance. Like I mentioned, software assurance used to just be for upgrades. Now it's for a lot more things. So let's kind of talk about that. Let me answer a couple of questions first. I have, will this method be applied to VM hosts with geo separation? I'm going to table that and let David try to answer that later. I can't think of that off the top of my head. And can you use synchronized commit for primary to secondaries within the same data center and simultaneously use asynchronous commit over VPN to another data center? Yes, that would definitely be a supported option. You could do that. You could do that pretty easily, and that's one of our clearly supported scenarios. And I have one last question that I'm going to answer, and I'll get a good laugh out of this. What would be the cost with Oracle? So I've written another paper for SIOS on the same topic for Oracle, and the numbers look very similar. It's just the graphs skew a lot higher. SQL Server is about $7,000 a core, roughly, give or take. Oracle's list price is $45,000 per core. And most of the same rules apply. The only difference is with Microsoft, you don't necessarily have to purchase licenses for your secondary servers, and we'll talk a little bit more about that with software assurance. Whereas Oracle, if the Oracle binaries are in a box, you have to license it. Sailboats don't buy themselves. So software assurance. Software assurance is typically about $25,000. Excuse me, 25% in your annual recurring cost. And that's an annual recurring cost, not just a one-time. And it's required now for cold DR licensing. It used to not be. We'll talk about that in a second. We used to get, if you bought a single license of SQL Server, up until quite recently, you used to be able to have a standby for free. That's changed, and it requires software assurance. One other thing is license mobility. Licenses float from one physical machine to another in a VM environment. This has been the case since about 2 or 3 years ago. SQL Server, or the Microsoft team, decided that you can only move a license once every 90 days. So this would apply both to physical clusters and VMs. So theoretically, if you don't have software assurance, you could only fail over your cluster once every 90 days without having license mobility. And the same thing would apply for a VM. So if you're running a SQL Server VM without software assurance, effectively you'd either have to turn off DRS in VMware or live migration in Hyper-V. Both of these are tools that move VMs around in a given VM cluster based on resource utilization all the time. So your VM's actually moving from host to host all the time, and you don't necessarily see it. So effectively, this is a requirement for a VM solution. Another thing is license upgrade. So if you did have to upgrade from SQL Server Standard Edition to Enterprise Edition, or even BI Edition, which includes some of the BI tools, if you don't have software assurance, you'd have to repurchase the license, so you wouldn't get any credit for the existing license you had. One other thing, and we'll talk a little bit more about this later, is a strategy to kind of mitigate some of the costs that also requires software assurance. So yes, a software to mitigate costs that requires you to spend more money. Within a given VM farm, if you license all of the physical cores, Microsoft allows you to run unlimited SQL Server. So say if you wanted to dedicate 5 servers in a VM farm to SQL Server, you can license all of those cores and you could run an unlimited number of VMs running SQL Server. However, you have to use have software assurance in order to do that. So this was the surprise on April 1st that we got. It wasn't an April Fool's joke, unfortunately. SQL Server software can be configured that if it fails, it can be recovered. So we all know this. We have availability groups, we have mirroring, and we have failover clustering. Traditionally, we got that second node free as long as we didn't use it. So, for example, with always-on availability groups, you can read the secondary databases. So if you're reading those or if you're taking backups off of them, you had to pay for that license. But if you weren't, if you were just leaving the server be idle or truly passive, you didn't have to buy an extra license. Well, Microsoft released a new document on April 1st, 2014, the day SQL Server 2014 came out, stating that each active server license with SA coverage, and that's the key 3 words there, with SA coverage, allows the installation of a single passive server. So effectively what this is saying is, if you don't buy SA, you have to buy another license for your secondary. I saw some verbiage in a document before this that looked very similar to this, but this was still a surprise in the new doc. And of course, I know a lot of you probably aren't out on 2014 yet. You may be thinking, oh, we're not going to run 2014 for a while, so this isn't going to impact us. The challenge with that is when Microsoft releases new licensing criteria like this, they do apply retroactively. And that's sort of a weird way to explain it, but effectively right now, the only licenses you can buy from Microsoft are for 2014, or under those terms. So even if you're buying 2012, you're buying them under the SQL Server 2014 terms. So basically, if you want high availability or DR, you need to buy software assurance. Surprise. So let's look at our total licensing cost for a 2-node SQL Server cluster running SQL Server Enterprise Edition. Here we have a 4-core server, and a 4-core server nowadays is typically going to be a VM, just because it's hard to find a single proc physical server. In looking at that, our total cost would be $34,370, and this would be to run a 2-node VM cluster. More traditional 6-core, that number doubles, obviously goes up to 68,740, and then we get into a 16-core box. So this would be a data warehouse box with, say, 4-core processors, and we're looking at 137,000 total. So those numbers add up really fast. And let's see what happens if we compare that to running Standard Edition. And the Standard Edition cost includes the cost of the SIOS DataKeeper Cluster Edition software. So on a 4-core server, we have $13,000 worth of savings. But if we go all the way up to the 16-core server, we have $74,000 worth of savings. If you have a couple of those, that can buy you a new DBA. It's a really tremendous cost savings using Standard Edition if you can get away with it. There are some additional ways. Oh, I actually have a good question here. So if I have SQL 2012 core licenses from last year, do I now need to buy SA for those to license my cold DR server? No. If you bought those licenses, you are grandfathered in under those terms. That would only apply if you were buying new licenses going forward. They can't retroactively change the terms on you. Fortunately for my old employer, because we would have owed them like owed Microsoft about $48 million when they changed the core terms. So no, you're okay for those. There are some additional ways to reduce your licensing cost. My favorite, probably the favorite that I recommend is to use the SQL Server private cloud and just license all the cores through virtualization. That does require SA. Another is to use standard edition. So standard edition, like we just showed in the last slide, you can really have or more of your licensing cost and still get a lot of the same HA and DR features. Another approach is to consolidate your SQL Server instances. This also tends to be a really good option for how you want to reduce overall cost. The challenge here tends to be more political than technical. There are some technical challenges because you're loading a lot more databases into your instance than you typically would. But you can kind of tune around those and work with that. What happens frequently, and I've seen this in a lot of organizations, a department will get a new application that'll require a SQL Server instance, and they'll pay for it, they'll pay for the server, and they feel like that's their server, and they don't want to share an environment with anyone else. So that's the real challenge in doing that. Another strategy, and this is really valid, don't pay full price for your development license. Obviously, if you're using something for production usage, you're going to have to pay. You're going to have to buy a full license for it. In a development environment, you can use MSDN licensing. For a large organization, it may be worth licensing all of your developers with MSDN. MSDN is still pretty expensive, but it definitely can beat buying real licenses. And additionally, your developers get value out of that software. Or if you're in a small organization and you just have a handful of developers, you can let them develop under Developer Edition. The challenge with MSDN is you can't use production data, which isn't usually too bad, and anyone who's licensed for MSDN can access those databases. Developer Edition tends to be a single-use license, so that's a little bit more of a challenge. So eliminate SAN-based cluster total cost of ownership. So let's have another quick poll question here. Is SAN performance an issue for your SQL Server environment? I had a feeling this was going to, oh wow, it's skewing away from where I thought it was going to go, but now it's going back. Okay, I'll go ahead and close this poll now. 57% of you voted, or 60% of you voted. That was closer than I thought it was going to be. 54% of you said yes, SAN performance is an issue. 46% of you said no. It's definitely something I see a lot in organizations as I go around. For a couple reasons. Managing a SAN is pretty challenging. SANs are also really designed around capacity instead of providing pure performance. So we'll talk about that in the next couple of slides. So one of the ways you can use DR, or provide DR in a Windows, in a SQL Server failover cluster is use SAN-based replication. We talked a little bit about this earlier. It's a little bit of a challenge. Storage array-based replication is complex and tends to be really expensive for DR. I've worked with several of the major storage vendors, and although these features are starting to trickle down a little bit, I've been seeing more and more. It used to be that you had to buy usually the highest end SAN to get these features, and additionally you had to buy additional software. So you didn't just buy the SAN and pay for support and get array-based replication. You had to, buy the array-based replication technology in addition to the expensive SAN you just bought. The other thing is you don't just have to buy one expensive SAN, you have to buy two expensive SANs because you have to have one in your second data center. So this is a real challenge. and you're also locked into one storage vendor, so it makes negotiating with your storage vendor to get lower cost that much more of a challenge. And from a database administrator perspective, it's a lot more complex. There's a lot more things that can go wrong when you're doing SAN-based replication than just managing a failover cluster. So it's out of your hands, and it's a lot more challenging. So here are the storage costs, and this is according to a recent ESG lab report from Dell that Dell published. I found kind of interesting. The 5-year total cost of ownership can range from approximately $387,000 to about $736,000, and that's for a mid-tier storage array. So this isn't even necessarily a high-end cluster, or excuse me, a high-end array. Nowadays, this will probably have a little bit of solid-state drive, but not a lot. So using a SANLess cluster with comparable performance and probably even better performance can eliminate this cost entirely. And this is where we can combine with the software licensing that we saved earlier to save customers more than $800,000 in 5-year total cost of ownership. One of the challenges is if your SAN starts running out of performance, really the only option is to buy another SAN. I've seen so frequently at customers where the particularly high workloads on a SAN drive them to not really fill it up, because what a SAN provides you is a lot of capacity and flexibility to manage that capacity, but it doesn't necessarily provide you with performance. When you're using direct attached storage, you're bypassing a couple of layers, so you're not going through a wire, through a switch, through a head unit to the storage. Your CPU is directly accessing the storage. You do lose a little bit of flexibility, but at the same time, your server can hold a lot of storage, and you can potentially buy solid-state drives for that at a much lower cost than baking them into a SAN. So in the SANLess cluster, we eliminate those SAN labor expenses, and we use standard server hardware, so the standard 2 or 4 U servers you might buy to run SQL Server now. You're using easy-to-configure local storage, so we're not having to allocate SAN disks to both servers or worry about iSCSI3 reservations. All that's handled for you. And you're using Windows Server Failover Cluster. You configure a disk that's very easy to do and turn on replication, and it's right there for you to implement into your cluster and then install SQL Server on. And typically, the other piece of this is the labor cost. In most cases, a SAN requires dedicated support from both a vendor and either a full-time employee to be a SAN admin or a consultant on retainer to provide maintenance and troubleshoot performance. Whereas if you're using local storage, it becomes just a lot more intuitive as to how to manage things going forward. So SANLess clusters can add a lot of flexibility. We can replicate between SAN and SANLess clusters, so we can have things running on that are on a SAN if you had one. Or one of my favorite scenarios here is in the middle. Here we have a 2-node cluster that would be a failover cluster. So we build that out as a SQL Server failover cluster, and that might be on your site. So here we have 2 copies of our database. In the event of a failover, these can fail back and forth with each other. And then here we have a 3rd node. And the reason why we have that 3rd node is strictly for DR purposes. And in this case, it shows in the cloud. So that could be in either Windows Azure or in Amazon Web Services. That 3rd cloud VMs are true DR. It's not necessarily part of our cluster because SQL Server Standard Edition has a limit of 2 nodes and a failover cluster, but it doesn't have to be. We can failover to that as we'd have to manually convert our application to that, but that provides us a true DR in the event that we were to lose the first 2 nodes. Here we have a VM cluster, so we have both failover and replication between our VM farm. So this is a really great solution for VMs. Traditionally, VMs weren't real friendly to using SQL Server failover clustering just because of some things you had to do to the underlying disk to make virtual disks to make them work properly. However, since we're not truly using shared storage here, that becomes a much simpler proposition. We don't have to concern ourselves with that. And then the last solution, and I've been doing a bunch of work with hybrid cloud lately, so this stuff's really interesting to me. It's just a full-on cloud solution. So if we wanted to run two copies of the software using Windows, Azure, Amazon, there's no real way to cluster that. You can use availability groups in the cloud, but once again, you're paying for Enterprise Edition licensing. You can do a very similar functionality here with Data Keeper, so it's also a really nice solution for that if you're using the cloud. So SANLess clusters can save hundreds of thousands of dollars, both in SQL Server licensing cost and more importantly, SAN total cost of ownership. I can't reiterate enough having the flexibility to be able to add local drives to improve performance. If you can switch out from spinning disk to solid state at a far lower cost than if you're using a SAN, and your performance is likely to be a lot better with local storage than on the SAN. It's an easy, cost-effective alternative to traditional clusters. You're using the same software technology from a Microsoft perspective, but instead of using SanDisk, you're building your own replicated disk. So you lose that single point of failure thing we talked about in regards to having a traditional SAN-based cluster. And we have far more configuration flexibility. I like to say DataKeeper is kind of this mix of database mirroring and clustering at the same time, but it's got all the good features of both. It has very similar functionality to using always-on availability groups, except at a much lower cost because you're using standard edition. Okay, now we're going to open up the Q&A, so if you have any questions, put them in. And I have one here that I'm going to go ahead and answer, and the question is, can the standard 2008 edition have active-passive cluster and mirroring to another standard edition that is far away from the primary data center? If you're using standard edition, you could do that. That is supported. The challenge with that is database mirroring in standard edition is limited to high safety mode, which traditionally means that, or not traditionally, which means that any transaction that takes place on that primary cluster, that active-passive cluster that you're mirroring from, is not committed on that primary until it reaches the transaction log in the secondary. So you're going to be impacting the performance of your, particularly of your writes to the primary server. Hang on, I have a couple more questions here. Let me grab them. One of the questions I had was how much overhead does SANLess replication incur? It's very light. It's a block volume it's a block level replication, so it happens at a very low level within Windows. So it's efficient, and it's actually tunable as well, so you can tune the performance. Can you cluster an on-premise data center with an Azure Cloud VM? Yes, you can. There are some challenges to that. Basically, you have to set up a VPN gateway through Windows Azure. If you take a look at my blog, it's documented there. And typically, you're also going to want to have a domain controller VM in that Azure environment, just to provide domain services in case you lose connectivity. But it's definitely doable. Also, the ease of doing that is going to depend on your ISP. There's 3 ways you can connect. One is point-to-site VPN, which if you just want to test, you can run from a VM within your laptop. I've done that. I presented on this topic at Path Summit last year. The second scenario is to have a site-to-site VPN, which is just a standard VPN connection. There. So that's also a challenge. But the third and the best solution is to have what Microsoft is calling ExpressRoute. And what ExpressRoute is your ISP can have a direct connection to Azure. So Azure will work. And then the last question, the same person has to follow up, do I need standard enterprise edition? So if you're using DataKeeper, you can have a 2-node standard edition cluster. So that enterprise would not be a requirement. One of the other, so a question is, what is DataKeeper? So DataKeeper is the product we're talking about that does SANLess replication, or block level replication, and integrates with, in this case, Windows Server Failover Cluster. It's also available for Linux if you're using MySQL or Oracle. You can build similar solutions. But basically what it's doing is block level replication of a volume, so a disk drive that's presented to your SQL Server in managing the data transactions going across at a block level. So anytime a 1 and 0 is written at that volume, you can see it. I had another question, can I mix and match SANLess clusters? Yes, so you could have, for example, the scenario we were kind of talking about a few seconds ago where somebody had an active passive cluster. You could replicate outside of that cluster to a third DR site. Unfortunately, that would require SQL Server Enterprise Edition because you're limited to a 2-node cluster. And then another one's just, what if I just want to do simple data replication to a third site? Can I do that with SANLess clusters? Yes, that's pretty easy to set up. What will recovery time objective can we support with DataKeeper application? So the one caveat to that is it's going to depend slightly on how far your transaction or how far your data centers are apart. Within the same data center, you'd expect the same recovery time objective as you would with the SQL Server Failover Cluster. You're going to be close. You're going to be sending those transactions synchronously. So you're going to have very fast for RTO. If you're sending them asynchronously, and typically we recommend that if you're using, if your second data center is more than 100 kilometers or 62 miles from your primary, then you may want to use asynchronous. With 10 gig bandwidth, over what distance? So sorry, the same person asked to follow up with 10 gig bandwidth. In the same data center, that's going to be virtually zero. You should be up as soon as you're back. Across distance, I have to know to answer that question further. So does anybody else have any other questions? I think I've answered everything that's come in so far. A 5-mile distance. Yeah, that would be near zero. And I actually had a question. Okay, good. I have a couple more questions coming in. What is the typical response time expectation when using synchronized commit between two data centers that are 1,000+ miles apart? I'm going to kick that one to Dave. I'd recommend using asynchronous. MSDN license, can I install SQL Server in a VM development environment? Yes, but you or the other people who are licensed for MSDN are the only people who can use those development environments. We got what edition of DataKeeper is needed? There's only one edition, and it's very cost effective. You can go to us.sios.com. And then I had another question, which I find amusing. Why doesn't Microsoft provide this? If you can do block level replication under SQL Server, so can Microsoft, why are they not doing it? Because they want to sell enterprise edition licenses mainly. That's my opinion anyway. With the cluster edition, does the Windows failover cluster see it as shared storage as two different disk stores? Good question. It's stored in that case. It sees it as a single drive. So if you're looking at a Windows Server failover cluster, it sees it as a single drive. So does SQL Server. It comes under one drive letter. Dustin had a question: how would you measure the transaction latency introduced in sync commit mode? And the secondary follow-up question that's right after that's another good question, and they're kind of tied together. If a failure occurs at the primary data center, how long does it take to come up on the remote data center if asynchronous is used? In both of those kind of, I'm going to say apply to each. So you're just going to be recovering. You're going to be recovering a little more, because remember, when you fail over in a SQL Server, and this will follow up to the next question, which is, if you fail over a DR, how easy is it to fail back once the prod server is back up? Your failover is always just this a SQL Server failover cluster failover. So we're not having to do anything under the hood. You're just going to failover cluster manager, failing over the instance. And the time it's going to take to do that is how many uncommitted transactions were in the log. So if there are more uncommitted transactions that SQL Server is having to recover from, you're going to have to do that. And then a follow-up question that I got to that. So if it fails over, then the cluster object fails to the remote site and takes a different IP, assuming it is a multi-site cluster. Yes, and with SQL Server 2012, you can assign multiple IPs that are in different VLANs. If you're using anything below SQL Server 2012, you need those IP addresses to be in the same VLAN. That's the one challenge I'd put around that. Let's see if I have any other questions. And the one thing I'll recommend if you are doing a multi-site cluster and having multiple IPs is not just to read the SQL Server documentation on it, but to read the Exchange documentation. Exchange has some things around IP management, and Dave Birmingham can probably comment on this, in multi-site clusters that I think is a little bit better, a little bit more intuitive than some of the things in the SQL Server scenarios. Another question is, how does backup handle this setup? It's just like backing up in a traditional SQL Server, but you could have a couple of options. So one scenario you could do would be add an additional disk for backup and replicate that disk so that you're backing up to a disk that's available in your cluster. Another scenario would be to just back up to a UNC share, and that's going to depend partially on your backup solution and what you're using. The one caveat I'll give you around backup, and this isn't so much a data keeper thing as it is a SQL Server failover cluster instance thing. If you're using the GUI, backup and restore in SQL Server can only, in a clustered instance, can only see a clustered disk. If you're using commands, you can see other comments, you can see other UNC paths or other drives, but through the GUI, SQL Server clustering can only see clustered drives for backup as well.
So Joe, this is Dave. Just to comment back on that question about the IP addresses in multi-site clusters. There's some really good articles if you Google about multi-site clusters. But primarily, a lot will depend upon what your application supports. If your application can support trying multiple IP addresses till it finds the one that's responding, that's going to give you your quickest recovery time. Your application will reconnect automatically. Otherwise, what happens when you use two IP addresses is DNS will be updated when the secondary server comes online with a new IP address. Depending upon your Active Directory replication of that DNS change, it could take some time before all your DNS servers are updated, and then of course you have to wait for your TTL to expire. So
right, that's a great point that you just when you said that it made me remember. Starting with the SQL 2012 client, so if your application hasn't been developed with the SQL 2012 client, or if you have a web app, you may want to consider deploying with this. There's the option to try multiple IP address directly within the client connection. So it will try both IPs, and that's for any cluster scenario. Do you remember the name of that flag? I'm forgetting it off the top of my head.
It's like a standby server or something like that. But yeah, in the connection string, you can specify a secondary server to try if the primary server is not available.
Yeah. Couldn't a load balancer solve the IP problem across boxes in different locations? Yes, but then you're buying the load balancer. So that's also a little bit of a challenge, but that is one way to do it. Like Dave said, there are some really good articles from Microsoft on dealing with multi-site clusters. The Exchange guys have been doing it for a long time, so I feel like they have a little bit better grasp of it. But thank you, that was the one I was looking for. Multi-subnet failover equals yes or true. Thanks, John. I couldn't remember that right now. It's been a while since I've talked about that deck. Anybody have any last questions they want to get in before we wrap up? All right, well, thank you, everyone. I hope you had a good session and learned a lot.
All right, thanks, Joey. Thanks for the great presentation, all the great information. And once again, I want to thank SIOS for sponsoring today's event. So please take some time to visit their website at us.sios.com to learn about all of their SQL Server HA solutions. The webcast was recorded, and you'll receive a follow-up email with links to view the archive. We'll see if we can get a copy of the slides from Joey as well that you can download. Also visit mssqltips.com to access all of our free SQL Server resources. I want to thank everybody for attending today. And when you exit the webinar, just take a couple minutes and fill out the survey. Feedback helps both today's webcast and future events. Thanks again, and hope you all have a great day.